Hello everyone, it's I Praveen. Here we are going to discuss few objective questions. So we are going to take first question. In this question they have given you two particles, one of mass m, another of mass 4m, and they have the linear momenta and the ratio 2 ratio 1. Then you have to find out what is the ratio of their kinetic energy. Then the question is so simple, and here mass they have given you the mass m, and 4m means first particle of mass m, another of mass 4m. Ratio of the linear momentum means if the means p1 by p2 is given like 2 ratio 1, then you are asked for, you have to ask for k1 by k2. So to solve this problem, we must know the relationship between the kinetic energy and the linear momenta. So we know the relation between the kinetic energy and linear momenta is P is equals to 2 root 2 mk. This relationship must be known to solve this numerical, that linear momenta P is equals to root of 2 mk. Now when we will write P1, then P1 is equals to root of 2. Mass of the first particle is m, and kinetic energy is k1. Then similarly, P2 is equals to root of 2. Rather than m, we will prefer to write 4m into k2. So this can be taken as equation 1. This can be taken as equation 2. So from here, P1 square upon P2 square is equal to here 2m k1 divided over 2 into 4m k2. 2 to cancel out, mass and mass cancel out. Then P1 by P2 whole square is equal to P1 upon 4k2. So P1 by P2 they have given you 2 ratio 1. 2 ratio 1 whole square is equals to K1 upon 4k2. So from here 4 ratio 1 is equals to K1 by 4k2. Then K1 by K2 is equals to 16 ratio 1. Right, so the correct answer would be 16 ratio 1. Great. Now we will go for the next question. Okay, so I'm going to skip this question. This is actually for you. Now just go with another question. Question number 3. So this is the third question. This one is a third question where you have provided with the, here they have given you that distance x is moved moved like this. Distance x is moved using the equation 3t square plus 4t plus 5. Mass is this, and time in first 2 seconds. Then you have to find out work done. Now we know that the work done can be calculated by two ways. First one is by using Fs, or dw is equals to integral Fts. There is one more way, but this can be used when force is constant. This can be used when force is constant, and this can be used when the force is variable. So here, how the force will be constant? If acceleration is constant, and whether the force will be variable if acceleration would be variable. So better to find out that which equation we should which equation we will proceed here. So first try to find out the acceleration, if it is going to be a constant or variable. So x equals to 3t square plus 4t plus 5. So first we will try to take the differentiation, dx over dt, that will give you the velocity, no doubt. This is 60 plus 4. Once again try to take another derivative, that is dv by dt. This is 6 only, that is 6 meter per second square, means acceleration is constant, and preferably we will use this equation. Now w is equals to force means mass into acceleration. Then this is displacement. Displacement means position of particle finally minus position of initially, which is not a particle initially, then work done equals to mass is 0.5. This is x. When you will put the value of x2 is here, value of p2 here, then you will get 3 into 2 square plus 4 into 2 plus 5, and this is minus here. When you will put 0 in the equation of x, then you will get only minus 5, and this is going to be cancel out here. This is 3 into 4 plus 2, and this is 4 into 3 12 plus 8 20. 20 into 3, answer is the 60 joule. So then 60 joule is the correct answer. Now just go with another numerical. Let's go with another numerical, and this is your third numerical, right? So here what you have to do here, okay, so here, so this is the question. This is the question. You have to find out the there is a body, there is a body of mass m. So there is a body of mass m, and lying on a rough horizontal surface, matlab having some mu, and there is a body having mass m and momentum p. So what they have given you? They have given you that after distance x, a body of mass m having momentum p, rough is surface is rough, stopped at a distance x, then you are requested to find out the coefficient of friction, right? So after x distance, it is going to be stopped, right? So after x distance, this is going to be stopped. So here uh, it is going to be rest. Now this numerical can be done by two ways. So this numerical can be done by two ways. So first I will give you the method one. What is the method one? Let's look at here. Method one is, you know that v square is equals to u square plus 2ax, right? So when it would be stopped, velocity is going to be 0. Then 0 is equals to u square plus 2a into x, right? So here this, how this is accelerated, basically it is not going to be accelerated, it is going to be deaccelerated, and this acceleration is given by a equals to you can write here a, or this is going to be deaccelerated. Once again, look at here. Initially I have given you one formula that mu is equals to a by g, isn't it? Mu equals to a by g. So here, how you can, if you here equals to mu equals to a by g, so try to put the value of a and g here. So from this equation, what we can write, from this equation we can write that minus u square is equals to 2 and a into x, and this is u. What is u? U is the initial velocity, but they have not given you, but they have given the linear momentum. Then p is equals to root of 2 mu, as I have told you earlier in the previous equation. And p square equals to 2 mu, then u is equals to p square by 2m. So from here you can write down the value of the p u square, right? So really very sorry, it is not a correct thing. That was the ratio between the potential kinetic energy and momentum. Here p is equals to m into u. From here u equals to p by m, that's why u square barabar p square by m square, right? So your square can be replaced by p square by m square equals to 2ax, means x equals to minus p square, equals to minus p square divided by 2m square x. This negative sign, so the retardation, don't bother about it. That's why m equals to a की जगह हम लिखेंगे p square upon 2m square x upon g. Then answer would be p square divided by 2 m square g into x. I hope uh, in your sheet you are getting this as a this this answer as a option A, right? P square divided by 2 m square g into x. There can be one more method. There can be one more method. What is that method? The you can use the work energy theorem. Work done is equal to change in the kinetic energy. Now the question is who is doing work here? So here you can see that only friction is doing work because this is the normal reaction, this is the mg, and this is the friction Fk. So here nothing is work is done by the normal RMG because both are making 90-degree angle with respect to displacement. Only Fk will make the work done here. Work done by the friction would be minus Fk into x, and what is the change in the kinetic energy? That is the final kinetic energy is 0, initial kinetic energy is the Ki. So from here you can write Fk into x is equals to Ki. Then Fk is mu into n rather than n. We will prefer to write mg into x equals to what is the initial kinetic energy? Initial kinetic energy is not provided, but we know that P is equal to under root 2 mu under root 2 mk. So P square is equal to 2 mk. So K is equals to P square by 2m. From here we can write down initial kinetic energy is given like P square by 2m. So from here we can write mu equals to P square divided by 2 m square g into x. Once again we are getting the same answer as we have done previously. So this numerical can be solved by both ways, by using the equations of motion as well as by using the concept of the conservation work energy theorem. This is basically work energy theorem. Now proceed for the next question. To the next question. This is once again a very good question. This is once again a very good question. And what is that question? Please. So here, cell is fired from the cannon. So there is a cannon from where a cell is fired with the velocity v at a certain angle theta. So we can put a cannon here. So right. So this is suppose this is a cannon. Suppose this is a cannon from here. A cell is fired, and definitely they will follow the parabolic path with a velocity v at some angle theta, and at the highest point, this is the highest point you can say, the highest point explodes into two equal pieces. Means if the mass is here mass is 2m, then this is going to explode into the mass m and another of mass m. Great. Okay. One piece retraces its path to the cannon. Once again, this is retracing its path means suppose this is the first one. This is coming back here. So this is going to be retrace and another. Okay. One is retracing. One is retracing its another path. You have to find out the speed of the another one. So you don't know what is going to be happen with the another one. राइट तो इसके बारे में तो आपको पता नहीं है, इसके बारे में पता है, ये वही रिट्रेस कर रहा है. तो आप हाईएस्ट पॉइंट पर जब जाओगे तो क्या होगा? एट द हाईएस्ट पॉइंट द वेलोसिटी वेक्टर विल बी v cos थीटा, क्योंकि ये उल्टा आ रहा है तो माइनस v cos थीटा. तो देखो दो पार्ट हुआ ना. तो वैसे तो ये जब मैक्सिमम हाइट पे जाता है तो इसका वेलोसिटी v cos थीटा हो जाता है. v sin थीटा, वही v sin थीटा इज गोइंग टू वैनिश. तो ये क्योंकि उल्टा आ रहा है तो अपने पाथ को रिट्रेस कर रहा है, दैट इज माइनस v cos थीटा. So here this whole thing is moving under the gravitation only, so conservation of momentum can be followed here. So here this, so from here we can see that 2m into v cos theta, this is the initial momentum equal to, this is the final momentum. This is the final momentum. So the final momentum is m into minus v cos theta, जो कि उल्टा रहा था, प्लस सेकेंड के बारे में we don't have any information. So here mass cancel each other. Then 2v cos theta here minus v cos theta is 3v cos theta is equal to v double dash. So the another particle has the velocity 3v cos theta. Now the next question is a theory question. Next question is a theoretical question. There is no need of any calculation. So here this is another question. Internal force can change. So what internal force? So internal force can change the linear momentum, but not the kinetic energy. Then momentum can't be changed because to change the momentum, external force is required. The kinetic energy, but not the linear momentum. The linear momentum as well as kinetic energy. Neither momentum nor kinetic energy. No, with help of internal forces, only kinetic energy can be changed. Only kinetic energy can be changed, but not the linear momentum. Because to change the linear momentum, an external force is required. So option B is the correct option. Now next one is okay. So this is also not a. This is seventh one is the seventh one. A having of mass m is clamped on a periphery. This okay. Great. So we can copy from here. Great. So a having of mass m is clamped on a periphery of the light circular disk. So there is a disk. So there is a disk. So there is a disk. Maybe there disk and a heavy ring of mass m. So there is a ring. There is a ring. Uh, which is actually clamped on the periphery. तो ये बीच में डिस्क है. यहाँ पे इन्होंने डिस्क दे रखा है एंड इसके पेरिफेरल पे यहाँ पे क्या दे रखा है. They have given you the ring. Okay. Have a ring of mass m. So mass m and light circular disk. This is a light. So what is meaning of this light disk? This is light. Light disk means ki having the mass 0, right? Okay. The system rotates in such a way that center moves in a circle of radius r with uniform speed v. Okay. So means axis of rotation is somewhere here, and the center is moving with velocity v. We conclude that an external force must be acting on the central particle. Okay, must be acting on the central particle. Must be acting on the central particle. Must be acting on the system. External force. Then try to do remember. Remember that this is not a ring or disk. Now this is basically going to be the system. This is going to be the system. So there is no meaning of central particle. There is no meaning of ring. There must be. There is. This is question number 7 now. Question number 1 second. I want to see. That is the question number C. Okay. No. There must be. Okay, having a mass m, right? A having a mass is clamped on the periphery of a light circular disk. The small particle having equal mass is clamped. Okay. There is one more thing. There is one particle is here. Great. there is one more particle in the second. Great. Clear. Very good. So, so you can imagine this this whole mass of the ring is acting under its center of mass. Means the whole mass of the system is m plus m, that is 2m. So the system is feeling the external force. Okay, so the system is feeling the system is feeling a the system is feeling a centrifugal force 2m v square by r, right? So mv square by r, other than m, here we will take the 2m, so 2mv square by r. So we can say that the 2mv square 2mv square by r centrifugal force is acting on the system. So here we must have the option C, option C. देखो इसको समझ लो, फिर भी क्या था, एक डिस्क था जो लाइट था, इसका पेरिफेरल पे एक रिंग था जिसका मास m था और इसके सेंटर पे एक पार्टिकल था। अब आपसे बोल रहे हैं कि भाई एक्सटर्नल फोर्स कहाँ पे लग रहा है, तो एक्सटर्नल फोर्स देखो कहाँ पे लग सकता है। तो सबसे पहले आप ये देखो कि अगर हम सिस्टम के मास के बारे में बात करें तो टोटल मास हो जाएगा 2m, और अगर हम यहाँ पे देखें तो ये आपका ये इस पे जो टोटल, क्योंकि ये सर्कुलर मैनर में घूम रहा है, तो हम कह सकते हैं कि अगर हम यहीं पे बैठे हुए हैं तो हम एक सेंट्रीफ्यूगल फोर्स इस पे बाहर की तरफ दिखाएगा, और सेंट्रीफ्यूगल फोर्स क्या होता है, ये होता है mv स्क्वायर बाई आर। तो यहाँ टोटल मास हो जाएगा 2m, और ये क्या आ जाएगा, अब देखो टोटल मास को यहाँ 2m आ गया, तो सेंट्रीफ्यूगल फोर्स मतलब ये बाहर की तरफ फोर्स करता हुआ दिखाई देगा हमें, क्योंकि हम नॉन इनर्शियल ऑब्जर्वर की तरह अगर हम यहाँ पे बैठे रहे तो। और सिस्टम पे आप देखो, क्योंकि यहीं पे सब कुछ है, तो इसका मतलब कहीं ना कहीं एक्सटर्नल फोर्स भी आप क्या कह सकते हो, उस पे 2mv स्क्वायर बाई आर लग रहा है, क्योंकि बैलेंस कंडीशन में है, राइट। तो इसके बाद फिर अगला जो क्वेश्चन है, क्वेश्चन नंबर 8 भी ठीक है, क्वेश्चन नंबर 8 में भी कुछ है नहीं, तो क्वेश्चन नंबर 8 भी आप देख सकते हो। क्वेश्चन नंबर 8 जो है इसका सी ऑप्शन होगा। चलो फिर इसके बाद भी हम एक और वीडियो अपलोड हम करेंगे, तो उसके बाद फिर आगे के कुछ क्वेश्चंस को डिस्कस करेंगे। ओके चिल्ड्रन, बाय।